This is an introduction session to Java. We'll cover the difference between IBM PC versus Mac machines, operating systems, high-level and low-level languages, compilers, features of Java, JVM, JRE, and JDK, and also applications of Java. If you think you already know these basics, feel free to skip this lesson, or else let's get started. First of all, let's understand the various components in a computer system. We have computer hardware at the bottom level, operating system in the middle, and various programs at the top layer. Computer software is a set of electronic circuits which performs all jobs that you ask the computer to do. There are two types of popular computer hardware designs in the market, the PCs and Mac. PC or personal computer was originally designed by IBM and it's followed by many computer manufacturers, whereas Mac is a design of Apple and Mac machines follow that architecture. Operating system, or OS in short, is a software which manages all the operations of computer hardware. Operating system acts as a middleman between computer programs and computer hardware. That is, OS facilitates various hardware services to the upper layer. The famous operating systems in the market are Mac OS, Linux, and Windows. Mac OS can only be installed on Mac machines, whereas Windows and Linux can be installed on PCs. Now let's take a look at the topmost layer. This part has various computer programs like Word, Excel, or internet browsers like Chrome. All these programs are executed on top of operating system. That is, OS takes commands from these programs and passes them to hardware. It also takes the response from hardware layer and gives it back to the programs. It's highly important to understand how these components work before moving into programming. Now let's define what a program is. A program is a collection of instructions that can be executed by a computer to perform a specific task. The process of making a program is called programming. But in our day-to-day life, we don't usually use the terms like program and programming. Instead, we say code for a program and coding for programming. Alright, now let's broadly classify the programming languages into two: high-level languages and low-level or machine languages. The languages that programmers use to write programs are called high-level languages. For example, C++, Java, or C#. The programs that we write in high-level languages cannot be executed directly on the computer because computers are digital devices and they recognize only binary data, meaning zeros and ones. So, how do we execute the programs we write? The programs that we write in high-level languages should be converted into a binary format before executing them. This binary code is called low-level or machine code. Now the question is, who will do this conversion? Let's find it out. There's a software called compiler which performs this conversion. For every language, there is a compiler. The programs we write in high-level language is commonly called as source code, and the process of converting source code into machine code is called compilation. That is, the source code is written in high-level language and the compiler converts it into machine code. Well, we discussed the common terminologies in programming. Now it's time to focus on our topic. Java is a very popular programming language. It was introduced in 1995 by Sun Microsystems and later it got acquired by Oracle. It's an open source language and it's free to use. Java is an object-oriented programming language. What is that? Object-oriented is a programming paradigm, and we'll dig into the details of that when we start learning coding in Java. Yes, we're going to cover a lot of exciting things as part of this course. Java has cross-platform support. What does that mean? That means the low-level code generated by the Java compiler can be executed on different operating systems. Alright, let's shed some light into it. Let's look back into the components of computer system that we just discussed. We know that we have hardware, operating system, and programs. Here, when we talk about programs, we mean machine code or low-level code. That is, the compiler has already converted them from source code. Suppose you have a Windows OS and you download a Chrome browser for Windows. you can install it and it will work fine in Windows. Now, if you try to install the same setup file that you have downloaded for Windows in a Mac machine, it won't work. Why? Because behavior of different operating systems is different. If you want to install Chrome in Mac OS, you have to download and install a Mac compatible version of Chrome. That is, the machine code generated for one OS won't run in another. Meaning, if you compile and generate machine code for Windows, you can run it on Windows machine only. And if you want to execute it on Mac OS, you have to compile it again on a Mac machine with a compatible compiler. This is a generic scenario, but Java is a bit different. Once the low-level code is generated for a Java program, it can be executed on any OS, meaning you don't need to compile it separately for each OS. That's cool, isn't it? But how come this be possible? Let's investigate. Unlike many other programs, Java code is not executed directly on operating system. Instead, it's executed on another software layer called JVM or Java Virtual Machine. That means if you want to execute Java programs, you need to have JVM in your machine. Yes, that's an additional requirement for executing Java programs. There is a compatible JVM version for every OS and it takes care of executing low-level Java code. Hope that you understand how Java enables cross-platform support. Now let's see how to set up JVM in your machine. You can freely download and install a software package called JRE or Java Runtime Environment. This package gets you both JVM and a set of Java class library files that are also required for executing Java code in your machine. So once you install JRE, you can execute all Java programs. But I'm not really happy with that because I want to write my own code. I want to be a programmer, dude. Can I write my own programs if I install JRE? The answer is no. If you want to write your own Java code, JRE is not enough. There comes the role of JDK or Java Development Kit. JDK has both JRE and Java development tools in it. That means if you install JDK, you don't have to install JRE separately because JRE is already included in JDK. Once you download and install JDK, you can develop your own Java code. We'll see how to set up JDK and write some exciting Java code in the upcoming sessions. Now let's see what can be done with Java. You can write Java code for a wide variety of applications such as mobile apps, desktop, web applications, web services and servers, games and database application. That means it's really worth learning Java and there are a lot of job opportunities in the market. Let's wrap up the introduction to Java here and I'll see you in the next video.